1966 Volvo P1800 for 46 years.
In the Guinness World
staggering
Records, an American driver, Irv Gordon, took his 1,966 Volvo P1800S past 3.03 million miles, about 4.89 million kilometers in his own private car. 2 major overhauls. 1 original engine block that kept going. How does a machine survive that long? Today, we'll turn his story into a practical guide. How an engine works, what really wears it out, how engine oil protects it, and what you can do starting on your next drive. Most passenger cars use the 4-stroke cycle. Intake, air, fuel in. Compression, both valves closed. Power, a spark ignites, pressure pushes the piston down. Exhaust, gases out. The piston connects by a pin and connecting rod to the crankshaft. Piston rings, seal pressure, and meter oil. The piston skirt slides on the cylinder wall. A camshaft and valve train time the breathing. A pressurized oil system. Oil pump. Filter. Oil galleries. Feeds bearings and cams. Splash coats, rings, and skirts. The goal is simple. Let parts ride on a thin oil film, not on each other. Where does fuel energy go? A large slice is lost as friction. Inside the engine, most of that friction comes from piston skirts, piston rings, bearings, and the valve train. Reducing friction here saves fuel and parts. Crankshaft and bearings. Hydrodynamic is the happy place. A pressurized oil film separates parts. Bearing shells use a strong steel backing and a softer overlay for embeddability to trap grit instead of scratching the shaft. Piston pin. It rocks more than it spins, so speed is low and contact tends toward boundary. Hardened, carburized pins and good oil supply prevent scuffing. Piston skirt. A big friction source. Clearances must be tight enough to avoid noise, yet loose enough to prevent seizure. Some pistons use oil jets for cooling and low-friction coatings on the skirt. Piston rings. The top ring sees the highest heat and load. Steels or nitrided rings survive with minimal oil. The oil control ring meters the film. Enough to seal, not enough to burn. Cam and follower. On a cold start, cams turn before oil gets their brief boundary contact. Materials and surface finish matter. So does oil chemistry. Cold starts in winter. Thick oil. Slow pressure. Cams and bearings may touch. Rich mixtures send fuel and water past the rings. With knocks and socks, they form acids. Short cold trips make white sludge emulsions. Stop and go city. Idling and bursts mean incomplete combustion. Soot and fuel dilute oil. Oxidation speeds up. Rings can stick. High load and hot climbs. High speed and temperature. Thin films and age the oil faster. Deposits harden in ringlands and turbo bearings. Dust. Poor air filtration accelerates ring and cylinder wear. Warm gently. Use the specified multigrade, 0 watts or 5 watts for cold climates. Avoid long idling. Keep cooling and PCV systems healthy. Give the engine a long, warm drive now and then. And follow severe service oil intervals if most trips are short. Cold starts are boundary lubrication. Be gentle. Engine oil is a designed fluid. Detergents keep parts clean and neutralize acids. Dispersants hold soot in tiny particles. Antioxidants slow oil aging. Many anti-wear agents do both. ZDDP forms a sacrificial film in heavily loaded contacts. Viscosity is the promise. Cold flow and hot film. Multigrades like SAE 5 watts 30 do both with VI improvers. Folded when cold, expanded when hot, though heavy shear can break them down over time. Long life came from consistent habits, steady highway miles, gentle warm-ups, timely oil and filter changes, and fixing small issues before they become big ones. Your car isn't a record-setting Volvo, but the physics is the same. Surfaces, heat, and oil. Control them and engines last. 3 million miles isn't magic. It's the right habits, the right oil, and a thin film you never see working every second you drive.